This is a maximum product problem. So it says that it is given that the sum of two numbers is 20. So it only says that the sum of two numbers is 20. It doesn't say anything about the numbers, whether they are positive or negative, or have the same sign, opposite sign, or anything like that. And then you are asked to find the maximum possible product. So when you multiply those two numbers, you get the products. You're asking what is the maximum possible product that can be reached by these two numbers. And then also, can there be a minimum product? For if you know those two numbers, that's going to add to 20, but can there be a minimum? So like it's a very interesting problem. So if you get a problem like that, and you can see that there are a lot of options. There are a lot of options. So it's not really obvious. So if you get a problem like that, what you need to do first is try to understand the question, like what is trying to tell you. So let's try to kind of analyze these problems. So what we're trying to do, we try to select some numbers and see what's going to happen. For example, let's say, because we know that the sum has to be 20. So let's pick 0 and 20. So you can see that these two numbers actually add up to 20. But the problem is when you multiply the two numbers, you're going to get 0. And then let's see like another number. Let's see how about 5 and 15. And you can see this also going to add up to 20. But when you multiply the two numbers, and you can see that you get 75. So it increases. And how about 10 and 10? If you put 10 and 10, and you can see it's going to add up to 20. But when you multiply the two numbers, so you see that you get 100. So you see that these numbers increases. So start with a small number 0, and you can see that these numbers increases. So let's see what happened like if you switch them. Like for example, what will happen if you put 18 and 2, like you switch the numbers. So you can see it's still 20, but when you multiply them, you can see that you're going to get 36. So the number is going down now. So that means, so if you look at, so that means increases and then like decreases. So there is a problem here. So that means we exactly don't know where this the maximum can happen. So if you get a general problem like that, we really don't know about them. That's why we need calculus to kind of understand, because we try to find where this peak happen, where there's a local maximum happen, or where's the local minimum happen depending on the problem. So also, so that means in these ones you see that those numbers are positive. But what happen if you pick one positive and one negative? So for example, let's say you're gonna pick -5, and then you're gonna pick 25. You can see these two numbers when you add then 20. So that means works for the first condition. And then but what will happen when you multiply, you can see you're going to get -125. So you get a negative number. So we are not interested in this one, because the reason is you are looking for the largest possible sum, largest possible product. So that means in this case, since you get actually it's a negative, since you get a negative number, so you can see that this is not good, because you get a negative number. So that means we disregard this case, because you get a negative product. And how about can both numbers be negative? For example, let's say -5, and if you're going to add another negative number, and you can clearly see that it's not going to work, because if both numbers are negative, and then you know that the sum is negative. So that means this also cannot be, because when you have two negative numbers, when you add them, you get negative sum. So if you get negative sum, it doesn't satisfy the condition. So that means that's no. That means we know that from this we learn that those two numbers has to be both either 0 or positive. A 0 is a valid situation in this case. So 0 or positive, because then you get a product with either 0 or positive. So that means that's the only condition. That means we cannot learn the problem now. Now let's start the problem, and then try to pick variables and try to set up the problem. So let's do that part now. So we kind of see that the maximum happen when both x and both two numbers are equal to 10, and at that time you get the maximum product as 100. So we kind of see that, but what we try to do, we need to justify that this is actually the case, because we don't know, because there are some lot of other options. So we exactly don't know that is the case. So that's why we need mathematics to prove this situation. So let's start the problem. So what we're going to do, we're going to first select the variable. So we're going to say let, so this is very important step, let x and y be the numbers, be the numbers, be the numbers with, and we also know the condition with x and y greater than or equal 0. So we know that this is the condition, because since you are looking for a maximum product and you cannot have negative numbers there. Okay, so now we're gonna bring more conditions. So then we know that, then you can say, then we know that the sum is 20. But that's given. The sum equals to 20. So that means we can write the equation. We can say, okay, so then x plus y has to be 20, because this is sum is 20. And then for later use, we actually solve for a y. So we can say y, according to this equation, if you subtract x from both sides, so this is going to be 20 minus x. So when you subtract x from both sides. So like easy way to remember these kind of things, if you move a term from one side to the other side, you switch the sign. That's the easy way to remember this one. Just switch the sign. If it is positive, it becomes negative. If it is negative, it becomes positive. So that's the easy way to do that. Okay, so we have this now. Now let's try to write the objective function. So what's the objective function? So the objective function in this case is the product, because you're looking for the maximum product. So we can write the product. So it's a product. So we're gonna say, let's say the product is P. You can see that it has two variables. So it is x, y. So there are two variables. So what is the product? It is x times y. That's the product. In algebra, we just write xy. We don't say x times y. When you write xy, that means it's a product. And then one thing you notice is that when you write it like that, it is a two variable function. Two variable function. So when you have a two variable function, you actually don't know how to find the maximum or minimum in this in calculus 1 course. It's a calculus 2 topic. So what you want to need to do now is you want to write this as a one variable function. So let's write this as a one variable function. What we do for that, we're going to remove one variable. That is exactly the same thing we did. Remember, we try to solve for y. That's the reason why we did that. Now we're going to substitute for that. So that means x. Y is 20 minus x. So we substitute for that. And then we simplify. When you simplify, you get 20 x minus x squared. And then you can see that once you do that, this is a single variable function. So you can see this is only one variable now. See that? So it's changed the variable. So it had two variable earlier, but now it is only one variable. Okay. So this is exactly how we explain. Like in our theory part, you might start with more variables first, but then you need to bring it down to one variable before you actually find the maximum. So let's try to write the problem now. So this is the problem we have now. So the problem says maximize px, the product function, which is a function of x, which is 20x minus x squared. What are the conditions? You can see on, you have to maximize this on. So if we just have this one, actually you can't do anything. On what condition? You will see that x has to be, smallest value of x has to be 0, because it cannot be negative. What's the largest value? So you can see, since the sum is 20, you can't have anything more than 20. So the largest value is 20. So that means under this condition, you need to find the maximum value. So this is the problem. So this is how you write the problem properly. So you have a problem and you also have a condition. So you have to be very careful to write this one. If you don't write it, this problem doesn't even have a meaning. So now what we try and do is we can use calculus now. So we can use calculus now. So use calculus, because you can see that this is a nice optimization problem or maximum value problem, or sometimes we use the absolute value. So what you need to find is the absolute maximum, not the local maximum. So the idea is we can look at the derivative. So let's look at the derivative, because we need to find the critical points. So look at the derivative. So if you look at the derivative, you can see that it is 20 minus 2x. To find the critical points, what we do, we set this equal to 0. So it's a set. You don't get this one. You set here. So that's a big difference between the two. Whether you get or you set. Here you set. So and then when you solve it, so you can see if this one are going to give you 2x equal 20. This is 2x equal 20, and then if you divide by 2, you can see the x equal 10. So you get x equal 10 as the answer. So what is x equal 10? That is the critical point. So the critical point is x equal 10. So that means the maximum or minimum should happen at this point. So and now what we do, we're going to evaluate the function at the critical point. So this is just a candidate. So we're going to evaluate because we are looking for the absolute maximum value. So that means we need to find what we do. We're going to look at we're going to evaluate the function at this critical point. So we're going to say what is P10. So you can see P10, which is so you can say that this is 20 times 10 minus 10 squared. So you can see that you're going to get 200 minus 100, which is 100. So you get 100 as the value. Now what we are not done yet, because we really don't know. We only know that there's a local maximum at this point. So what we need to do is we also need to evaluate the function at the endpoint. So we know the endpoints. What are the endpoints? One is 0, but you can see that when you plug in 0, you clearly get 0. And the other one is 20. That's the reason why we need those endpoints. So we can plug in 20, and you can see when you plug in 20, so you get 20 times 20, and then minus 20 squared, which is also 0. That means these are all 0, so you clearly see that that is the largest value. Because if you don't do this step, we really don't know. If you have a general problem, we really don't know whether that's a maximum, because we only know that there's a critical point. At the critical point, the maximum or minimum can happen. And then also we are looking for the largest value, the absolute maximum value. So it's not a local maximum value. So that is one of the mistakes that students do. So they think this is a local maximum. No, it's not the case, because sometimes what can happen in theory, you can see there can be situations like this. So you can be a maximum, and then also can be like that. So in this case, actually, you can see the maximum happen here. So that means if you don't know the endpoints, you really don't know the final answer. So you need to be very careful with this one. So the local maximum is not always the absolute maximum. Okay, so that means, so we find this one. So that means in this method, then we know that, because this is how we find the absolute maximum. We find the critical points, evaluate the function of the critical points, and also evaluate at the endpoints. These are the endpoints, and then pick the largest as the absolute maximum. So then from this one you can see that. So the maximum possible product that can obtain is 100. That happens when x equal 10. But you can see when x equal 10, y also equal 10. So you can see that when x equal 10, you can see y equal, which is 20 minus x, so which is 20 minus 10. So that means 10 again. So that means when x equal and y equal 10, you get the maximum possible product. Now we're going to finalize the answer like this. So we're going to say thus the maximum product can be reached by the two numbers is 100. The maximum product that can be reached by the two numbers is 100 when the numbers are 10 and 10. There is also another way to see this argument. So I'm going to call this like method 2. So the first we used the technique like how to find absolute maximum. So what we did, we find the critical points, evaluate the function at the critical points, and also evaluate the function at the end points and pick the largest as the maximum value. That's how we normally find absolute maximum. The second method is, since you know the first derivative, so you know that the f prime x is, so you get 20 minus 2x. Now what we do, the second method is you can use a second derivative test. So what we're going to do, we're going to look at the second derivative. So if you look at the second derivative, so you can see the second derivative is in this case negative 2. So it's a negative number. If it's a negative number, so you can see that then what will happen, even at the critical point, which is 10, you can see this is negative. So that means at the critical point, by the second derivative test, we know that since this is negative, there should be a maximum at the critical point. So there is a maximum. So has a maximum at x equal 10. So that's like another argument that you show that there is a maximum value here. And then since this is only one critical point, remember like in theory we talk about this one, since there's only one critical point, that maximum value has to be the absolute maximum. So so there is a since this is only one critical point, otherwise we cannot say that, then there is a maximum product. So maximum product, then there's a maximum product at x equal 10, and then after that the rest is the same, because we know that when x equal 10, and then we know the y equal 10, and then we can write, so the maximum product is, so is the rest is the same actually. So the maximum product is as you can say p max, which is 10 times 10, because we know that happen when both are equal to 10. So 10 times 10, which is 100. Okay, so that's the argument. And also for, so this, since this is the, like a, you know, like a first example, I would like to explain it like that, but later we're gonna skip some of the steps because we really know what's going on. There's another method to do this problem. So for example, this is like a special case. So you can see, so I'm gonna say another method. So the method 3, this method actually does not use calculus. So do not use calculus. Okay, so you can see so does not use calculus. This is like a very interesting argument. So let's look at the graph, the function. You can see our product formula became 20x minus x squared. So if you look at the factors, you can see it is x and 20 minus x, and this is also a parabola. So you can see this is like a upside down parabola. So it's a parabola. So when you have a parabola, you really don't need to use a calculus, because you can see the graph looks like this. So it is, so there are two zeros. There's a one zero at 0. The other zero is 20. So you can see the graph going to look like that. So this is 20, and then you can see by symmetry the maximum should happen at the middle point. Middle point is 10, because it's 0 plus 20 divided by 2, so it is 10. So you can see that at 10 you get the maximum value. So this is the other way. So it's like when you have a parabola, you don't need to use a calculus, because the symmetry, you can actually get the value. It doesn't work for cubic functions. So it should be like a parabola like that. Okay, so and then so you can see that the maximum, so the maximum happens at, you can see, happens at x equal 10. That's like a middle point. So you know that from the theory, the middle point is normally like x equal negative b over 2a. So that's actually the point. So that's where that maximum happen. A maximum minimum happen depending on whether it is a you know, open up, open down, or sometimes it's a concave up or concave down. So depending on that, the maximum minimum, but it happened at this point. It's very interesting. It always happened at that point. So that's the same idea, but here we can see that we didn't use calculus for this one. So this is like another argument using properties of parabolas. Okay, so let's try to answer the last part of the question. So the last part of the question